and the amorphous solids. Number one, as I told you, the crystalline solids, long range orderly arrangement of the constituent particles like atoms or molecules. Long range orderly arrangement. While in amorphous solid, they are randomly arranged. Even if there is ordered arrangement, it is only short range. So, orderly arrangement of the particles, randomly arranged particles. Second, the particles in crystalline solid have definite shape, while in the amorphous solids, the particles do not possess definite shape. So this we compared with the sugar and alcohol compounder. Third, the crystalline solids are an important property are anisotropic. Anisotropic, while amorphous solids are isotropic. What we mean by isotropy and anisotropy? Let me explain it later. This is a very important difference. So let me explain it later. Fourth, when you compare these two, crystalline solids are real true solids. What we mean by true? These are the actual solids. What about amorphous solids? They are not actual solids. Then they are called pseudo solids. They are not actual solids. So they are also called the supercooled liquid. Why we call them supercooled liquid? So if you take water, a liquid, and cool it, it freezes into ice. So it is freezes into ice means the supercooled liquid. So the amorphous solids possess many properties of liquids, not the properties of solids. So they are termed as supercooled liquids. Then when you compare the heat of fusion, you know what we mean by heat of fusion. You take a certain quantity of a solid, say 1 mole of a solid, you heat it to melt. For complete fusion, complete melting, it requires certain amount of energy that can be expressed in kilojoule or kilocalories. Say amorphous solids, crystalline solids, when we compare, the crystalline solids possess definite heat of fusion. We can say how much heat is required for a complete fusion of 1 mole of a solid. But amorphous solids do not possess definite heat of fusion. It varies. So this is a very important difference. Next, very important difference is the melting point. Crystalline solids possess short melting point, while amorphous solids do not possess short melting point. What we mean by short melting point? I think you all know about the melting point, the temperature at which a solid completely converted into liquid. See, consider I take a piece of solid, I try to find out the melting point. How will you find the melting point? Keep a thermometer and start heating the solid. When you heat, the temperature gradually increases. You can see in the thermometer. At a particular instant, the temperature remains constant. At that time, the total solid melts sharply, melts completely. So till it melts, the temperature remains the same. So you can note the temperature. This we call it a short melting point. This you do again and again. The same temperature you can observe. This is called a sharp melting point. Why? When you find the melting point of an amorphous solid, say example plastic or glass. So take a piece of glass and heat it, keep a thermometer, and if you observe, the temperature does not stop at any particular temperature, particular value. It goes on slowly rising. But when you observe the glass piece, it melts at one portion and the other portion remains the same solid state, in the solid state. And the temperature slowly increases. It doesn't stop anywhere. So for complete melting of the piece of glass, when you observe, it takes a temperature range. So it does not possess sharp melting point. So we can say crystalline solid possess sharp melting point and amorphous solids possess amorphous solids do not possess sharp melting point. So this is important characteristic. So what are the examples for crystalline solids? All metals, salt are examples for crystalline solids, sodium chloride salt, etc. Amorphous solids examples are plastic, glass, rubber. These are all the examples. In isotropic and anisotropic, what we mean by isotropic and anisotropic? Isotropic means uniformity in all directions. See, in solid state, we mean isotropy. Isotropy means if you measure certain physical properties like refractive index, electrical conductance in a solid, if it shows same value irrespective of the direction in which you measure, it is called isotropy. If the physical quantities like refractive index, electrical conductance show same value in all directions, it is isotropy. Different value in different direction means it is anisotropy. So unexpectedly, crystalline solids possess anisotropy, whereas amorphous solids possess isotropy. How? See, you can consider a sodium chloride crystal in which Na plus Cl minus ions are regularly arranged in a three-dimensional pattern. So like this. So if you compare the arrangement, you can observe the anisotropy in crystalline solid. So you consider these three layers of the solid. See, if you observe the arrangement of ions in this direction, so in this direction, first we see Na plus, second Cl minus, Na plus, Cl minus. So this is one way, one order. But if you observe in this direction, see, we have Na plus, Na plus, Na plus. Here Na plus Cl minus, Na plus Cl minus, but here only Na plus. But if you observe in this direction, you have Cl minus, Cl minus, Cl minus. Sodium chloride is a crystalline solid, but when you observe the arrangement of the ions, it differs in different directions. This is called the anisotropy. So this is the best example for anisotropic property. So crystalline solids possess anisotropy. Crystalline solids are anisotropic. Amorphous solids are isotropic. They show same properties in all directions because it is randomly arranged in all directions. So these are the main differences between crystalline and amorphous solids.